Welcome, everybody. Thanks for joining me today for my webinar. I'm going to be talking about adaptive QA simplified and how you can elevate your Elekta Unity workflows with two of our patient QA Halo solutions, IMSure 3D and LinacView. And we also offer the Delta 4 MR Phantom that can be used in that workflow as well. Okay, since most of you are here, I'm sure you are familiar with Elekta Unity. It's a real-time 1.5 Tesla MR based Linac that allows for online imaging and motion tracking. And it is a daily adaptive planning for personalized treatment for precise IMRT VMAT delivery with reduced margins. And as most of you are aware, there's a very quick trend going towards both online and offline adaptive therapy treatments. So having the ability to have confidence in your secondary plan checks and to monitor every delivery is getting more and more important. The online adaptive workflows really do offer some unique QA challenges that we as physicists aren't necessarily accustomed to in the clinic. First off, for the MR-based Linacs, the magnetic field does impact detector array accuracy. So if you're trying to use a detector array for your pre-treatment QA, that needs to be a factor. There are very few MR-safe QA tools available. We do offer the Delta 4 MR array for pre-treatment QA. There are also tight bore sizes which can limit phantom use. And then, as you know, online adaptation while the patient's on the table really does prevent pre-treatment measurement-based QA for complex IMRT and VMAT plans. So those types of plans need to have QA in other areas incorporated and kind of beefed up to make sure they're very robust. So I'm just going to go over the general workflow for a Unity patient. Of course, it starts, as with all plans, a patient starts with their treatment planning. So they get a CT, MR, and they do dosimetry planning based on that. Once the plan is approved by the physician, it starts through the pre-treatment QA process. Now, for an online adaptive workflow, this is the process before fraction 1. So in this case, you would do your traditional secondary plan calculation check and very likely a device-based pre-treatment QA. Once that is approved, it then moves on to the first fraction setup and treatment evaluation. And with the Unity, that's where MR imaging and online adaptive assessment happens. If it's decided that there's been changes in the patient's anatomy, then it initiates the online adaptive planning process. Now, it's important to note with online, that means while the patient is laying on the table, waiting for the new plan and all the subsequent checks to be completed. And so that time is of the essence and efficiency is of the essence in that case. So with our Unity patient QA Halo solutions with IMSure 3D and LinacView, we can help automate and streamline that QA process and elevate it to a quality level that makes you feel confident in the fact that you're not able to do your traditional pre-treatment QA in those workflows. Because, of course, while the patient's on the table, you can't put a device on the table to do that. So really, you are totally reliant on your secondary plan check, and you want that to be a very robust plan check. It should be as equally as accurate as your treatment planning system algorithm itself. Once the secondary plan check is approved, then it can move forward to the actual treatment delivery. Now, again, this is a case where you haven't evaluated that treatment delivery yet. So that patient gets delivered, and there's a little bit of a gap there in terms of knowing how the machine is performing for that particular delivery. And I must note that these types of plans are they are very tight margins, sometimes higher dose. So knowing what's going on with your treatment delivery and your machine is quite important. So to kind of cover the requirement of treatment delivery QA, some centers do a post-treatment device-based QA for every fraction, but that is very, very time intensive, and most clinics can't really take on that workload. So luckily, we have automated solution that really helps with that. So with our Unity Patient QA Halo software set, the IMSure 3D is a very robust plan secondary check that has a gold standard Monte Carlo algorithm called SIMOCA, which gives you an equal level of accuracy and precision as the treatment planning system itself. And I'll discuss later some publications where they looked at this compared to the Monaco treatment planning system. Also with IMSure 3D, it's fully automated. So as soon as the treatment plan is exported from the planning system, it will pick up that plan, do the calculation, do all the analysis, and send any alerts and create reports as automated and let people know what's going on. That can be set up through email. For your first fraction, as I mentioned, the Delta 4 can still be used, but at the same time, you can also incorporate our LinacView log file-based analysis solution. So again, this is all automated. As soon as the plan is exported from the treatment planning system, it will grab that and calculate the expected fluence. And then LinacView software at the end of treatment delivery, we'll grab the accelerator log files, and it will do a calculated fluence based on machine performance and do a side-by-side or a gamma comparison of the two. So that way you have assurance of the deliverability of that plan before you have even treated. And it gives you a semi-baseline for the delivery of that plan and pseudo-adaptive plans moving forward. Now, when it comes time to actually deliver the plan, so whether you did an adaptive plan or you went with this first fraction treatment, you again get that LinacView log file fluence comparison. And so that gives you confidence in the deliverability of the adaptive plan or the original. And you don't have to do the post delivery machine QA that could add on a significant amount of workflow for physics staff. Again, this is also automated alerts, so if there's anything that is an issue, you will know it. And I'll follow up with giving more details of both the software, but I want to start with the workflow. One nice thing also to note with LinacView is you're able to generate a log file based RT plan, which you can then export and import into your treatment planning system and do a calculation based on the machine parameters. And what's nice about that is you're getting a dose calculation based on apples to apples algorithms, beam models. You're using the beam models and algorithms within your own treatment planning system. So any comparisons and deviations between your intended treatment and your actually delivered treatment are purely due to machine performance issues in that case. So that's nice to have that unbiased comparison there. So I'm going to dive a little deeper into our solutions. IMSure 3D, as I mentioned, is our SIMOCA-based plan check software. It's a very gold standard software. It's actually based many years ago on the Monaco Monte Carlo algorithm, but over the years it was optimized for speed while maintaining accuracy. So it truly does allow for very quick calculations. Here's an example. If you had a small voxel size, very complex type plan, it's still calculating within less than 2 minutes, which in terms of an online workflow for the quality that you're getting, that is totally reasonable. But even for your standard workflows, if you have, you can use this, you don't have to use it just for your online workflows, you can use it for all your standard treatments. And again, the automation fits any workflow and the time is even quicker. Really, the only time you would really be aware of these calculation times is if you force a recalculation and maybe you reviewed it and for some reason you want to change the voxel size and you're forcing a recalculation. Otherwise, it's all happening kind of automated behind the scenes. As I mentioned, as soon as the plan is exported from the planning system for delivery, IMSure 3D will grab it and just start doing that calculation. So you'll be notified when it's done. So you're not really aware of that delivery time at that point or the calculation time at that point. In terms of the metrics that are displayed and the automation, you're able to look at side-by-side comparison of your organ at risk or target volume metrics, and it will show you differences. What's I feel is even more important is you can look at an interactive 3D view of the gamma differences and the tolerances, as well as DVH displays. So if you do have a plan that has some gamma deviations that are maybe outside of your specs, you're able to go through and see where those exist. That's always been an issue with pre-treatment QA in a device when you're not looking at things in the patient perspective with the patient density and anatomy, that it's really hard if you have a plan that's failing or borderline to really deduce, well, what does that mean within the patient? So this gives you that information from a plan calculation perspective. All right, so I'll dive in a little bit to our LinacView. Again, that's our automated log file machine performance, delivery performance, patient QA solution. It provides automated QA analysis, alerts, notification, and it's doing it for every fraction. So it's not just for pre-treatment, it's just automatically doing it every time you deliver a plan. And again, this doesn't have to be used just on your online adaptive machine. You could put this on any of your Linux. It provides real-time log file monitoring for easy fluence comparison, as I mentioned, integrated into any workflow. But what's kind of takes us to a different level is it really provides automatic machine performance analysis to assess any delivery issues. So if there is an issue and you're able to dive in a little bit deeper and see, well, what is the issue? Do I have an issue with my leads, or is it my dose rate ramp up, something like that? The results appear in a dashboard literally seconds after delivery, and you can see whether they passed or there's an alert at this level. You can dive deeper, and I'll show you that in a minute. Alerts, you can configure it so any alerts that do happen, you are emailed so that you're aware that there's something that you need to look into. Otherwise, no news is good news. So, which is nice as a physicist. We don't have as much time these days to go looking for issues like we used to with our weekly chart checks. Things need to be automated. Issues need to easily rise to the surface so we can focus our time where it matters most. Now, the results are stored in a patient-centered database, so you're able to go kind of retrospectively review, look at data trending if you want for machine performance. When you dive in a little bit deeper for each analysis, it takes you to this batch view. The comprehensive analysis tools are available starting with the summary interface here. So this allows you to quickly assess how each delivery parameter compares to the user through customizable tolerances. So you're able to say, I want to have this meet this expected criteria within a specific tolerance. And what you want to do is set these tolerances tighter than your Linac, because that's sometimes feedback it gets like, well, my Linac will tell me when something's wrong. Well, yes, it will, and it will fault out, and maybe your Linac will go down. And so you want to be proactive with this information. So you want to kind of come up with a set of tolerances that are tighter than your Linac, so you're able to catch these issues before they start giving hiccups on your machine or bring your machine down. The data is organized within tabs, so there's a lot of information here, and it can look overwhelming at first, but really it's something that you would only dive into if you really needed to. The colored tabs are associated with the clinically relevant alerts. So those are the ones you're most would be most concerned with, and they come color coded depending on whether something you need to look into. So green is good, red would be a failure, yellow would be an alert. All the black tabs are just tools you could use if you had some clinically relevant issue that you want to dive down deeper into. As I mentioned before, RT plans can be easily generated to bring into your treatment planning system and do your comparisons there. You could then look at any issues on the 3D dose view within your patient anatomy. So that's nice. There's very easy PDF reporting and delivery performance documentation for your records. So that's a general overview of our software. I'm not going to go over the performance of the Delta 4 Phantom, MR Phantom, but we can give you that separately if you need that. But for now, I'm going to go into a few publications that have come out recently that look at both SIMOCA, Monte Carlo engine, that's an IMSure 3D, as well as LinacView. And one specifically, this one for the Elekta Unity workflow. So this is a study that validated Monte Carlo-based dose calculation engine, which is SIMOCA. We used an IMSure 3D in a 1.5 Tesla magnetic field treatment delivery environment. So they validated SIMOCA against the Monte Carlo treatment planning system in a number of ways. They compared it to water and heterogeneous phantoms. They also looked at 161 SBRT plans across 5 sites. And they looked at gamma analysis, target, OER metrics, and run time, calculation time, and assessed all those. So what the results showed was comparing both algorithms to phantom measurements, they both tended to agree with phantom measurements with gamma at tolerances at 2%, 1 millimeter at the 99% level. So that goes to show that both SIMOCA and Monaco are kind of side by side in terms of how they compare to each other. SIMOCA, their comparisons with SIMOCA versus Monaco, they did 3D gamma analysis at 3%, 3 millimeters, and they did find some difference, but they generally agreed at this level of greater than 95%. Now, that 5% that did disagree, what they found is that SIMOCA tended to give a little bit higher V95 and also a little bit higher D2. So that's like the hotspot indicator. So SIMOCA kind of shifted things slightly hotter compared to Monaco. The organ at risk deltas were mostly less than 2% compared to Monaco and SIMOCA. They did deduce that this really what they felt the systematic difference between these two was in how the two dose engines, Monaco and SIMOCA, model very small radiation fields. So particularly the 1x1 field size. And this, if you have a very highly modulated plan, very small, you may have a higher component of these 1x1 segments that may lead to some output, some mismatch. And what they found is that Monaco tended to underestimate the output factor by about 4.4%, and SIMOCA overestimated it by about 2.2% versus measured. So it could be that there really needs to be in those models, to create those models, the vendor maybe should start incorporating 1x1 data or something in there is what their recommendation was. But still, overall, it was an excellent agreement. They also found that the total calculation time for the SIMOCA was about 2 to 3 minutes for their plans. And again, that's very suitable for same session adaptive plan checks. It's nothing that is going to cause any significant delay for the treatment. That's 2 to 3 minutes is really nothing. So their conclusion was that oops, I think I jumped ahead too much. Their conclusion was that SIMOCA does enable rapid independent Monte Carlo dose verification with accuracy equivalent to the Monaco treatment planning system. And really that's Monaco, that's considered the gold standard of Monte Carlo. So SIMOCA as a secondary check is equal to that. And that does an excellent job at supporting online adaptive MRRT planning and approval and keeps the workflow moving without any delays. The next research paper I'll discuss is looking at the independent, again, SIMOCA as an independent Monte Carlo dose calculation algorithm. And it looks at its ability to identify single isocenter multi-target radiosurgery targets that are most likely to fail pre-treatment measurement. So it's using SIMOCA as a predictor of which targets might fail. And what's important here is that's very helpful if you want to replace, since you can't do pre-treatment device QA, you want to have a solution that could be equally as predictive as where your issues are as a plan check. So this is going to this shows that IMSure 3D with SIMOCA can be used for those cases where you can't do device-based pre-treatment QA, and it will give you valuable information. So their methodology was that they did a retrospective review of 31 single ISO multi-target SRS plans. And they did a per target comparison where they compared the treatment planning system versus SIMOCA. And then they validated both of those against the SRS map check and looked at gamma pass rate. So they looked at a total of 217 targets. And of these, 28% showed a greater than 5% difference between treatment planning system and the SIMOCA. The key drivers for those differences they found were tissue heterogeneity, off-axis distance, smaller target volumes, higher plan modulation. So all of those things that kind of spilled over into the other study where things start breaking down when you get really small. And you start throwing in tissue heterogeneity in there as well. So their targets with the largest treatment planning system versus SIMOCA discrepancies, what's interesting is those also had poor map check results. So they found that there's 71.5% of those with the discrepancies also failed map check in those areas. Map check did agree more closely with SIMOCA. So that's kind of interesting, and I actually need to probably go back through. I didn't note it here, but I do not believe their treatment planning system was using a Monte Carlo based algorithm, so it was just a standard algorithm. So this goes to show that SIMOCA truly is like a gold standard dose calculation that's equal or even better than the treatment planning system algorithms that are out there. And in this case, it agreed and predicted what map check was seeing as well. Its GPR was 99.4% versus the treatment planning system was 93.1. So to me, that's a significant difference, even though you might think that 93.1 is still good, but you are getting much more confidence out of 99.4. You're not missing much of anything in terms of predicting which would potentially fail actual measurement device measured QA. So what they concluded is that IMSure 3D with SIMOCA is effective in flagging problematic targets early, enabling replanning before pre-treatment measurement. So again, this is something that is directly important to an online adaptive workflow. If for some reason an adaptive plan is pushing the planning system too much, SIMOCA could potentially predict which ones need should be looked at again from a planning perspective. So again, this supports adaptive rapid turnaround workflows because time is not an issue, and especially where physical QA is limited. So I think that's a great study to look into. The last study I'm going to talk about is focused more on our LinacView side. So here they evaluated 4 Hz log files and secondary Monte Carlo dose calculations as a patient-specific quality assurance option for VMAT prostate plans. So they looked at 30 Monaco prostate VMAT plans. So again, this is a Monte Carlo-based planning system. They did pre-treatment QA as well as on-treatment QA with LinacView. And they were looking at a gamma of 2%, 1 millimeter, 20% low dose threshold, and the MLC error sensitivity. And what they found here were the results for the pre-treatment SIMOCA gamma passing rate was 96 to 100%. On treatment, LinacView gamma pass rate was 93 to 99%. And then the log file RT plan, we're able to detect errors that they introduced into the plans greater than 0.5 millimeters. So Uh, very good for really assessing the deliverability of the plans and seeing where there's issues very early on. So again, kind of supports the fact that you can set your thresholds for triggers much tighter than on the Linac itself. So in conclusion, Simoca and LinacView support accurate, efficient QA while minimizing the need for phantom-based checks, especially when you can't do them in general. And I think both of these things, along with our, I haven't talked about it today, but I will in a future webinar, with our Adaptivo, it's our 2D EPID dosimetry solution. All of those are playing into sort of supporting a new realm of patient QA. I feel that's coming down the pipe. We realize now that there's not value added in doing device-based QA for every single IMRT, for every single VMAT. But as it stands, we are kind of at a point where that's kind of required. However, there is going to be a shift, I believe. AAPM's kind of looking into this now, where clinics will be empowered to have more risk-based QA programs established. So that would be based on what other QA you're doing along the whole patient QA workflow, and are there certain types of plans where you feel confident the risk is low, that you don't need to do device-based pretreatment QA. And again, that really is necessary in our clinics these days. It's a huge burden on physics staff to do this work, and you really should only be doing that when it's warranted. But you shouldn't just take that away without beefing up QA in your other areas. So anyway, just kind of something for you to think about as you go down the road with looking at and reevaluating your patient QA solutions. That's all I have for today. Looks like I'm at the end, but if anybody has time, I'm happy to answer.
Yeah, it looks like we had one question submitted so far. If you do have questions, just please enter them in the chat or the Q&A tab at the top of your menu. This person was just wondering if we could share the links to the studies that you touched on today.
Yeah, I certainly will.
Awesome. That's the main one I have that came through.
Ashley, you could probably send that out to the group, right? After, if I give
Yeah,
them to you.
we can include it in the recording, in the email with the recording link. We'll include them there.
Great. Yeah, and those are several of those, a couple of those are very recent studies. So
one came through. What is the workflow to create the B model in Simoca?
It requires some data measurements. Some you can get from the commissioning data you probably already have, but basically what we need are profiles and output factors for a range of field sizes from you. So we do ask for output factors down for smaller field size. We also need some diagonal profiles. But once you get that to us, the value in the modeling process is excellent. We're able to see your whole energy spectrum for your beam. We can let you know whether, maybe there's an issue with a small field output factor or something looks off, because we can compare the spectrum of your beam data and energy spectrum of your beam energies to what a standard, let's say gold standard Varian or Elekta Linac should look like. So it's adding more than just a beam model. It's really adding confidence in your whole commissioning of your Linac and the integrity of your beam model within your treatment planning system as well. And sometimes that can be tricky to have reassurance of that. Often people inherit legacy beam models. You weren't the one taking the data. It's really can be really hard to assess the integrity of the whole spectrum of data collected. I mean, there's a lot of data collected during the commissioning process. So it's a great tool to use even from that perspective. And then once you get that optimized and your treatment planning system data is excellent as well, then you've set the stage for an excellent QA program.
Awesome. Thank you, Vicki. It looks like, are there papers on the use of LinacView generated log files to recalculate the plan?
In the treatment planning system,
They don't
I
specify.
yeah, I'll have to look and see if there's any new, because there's new papers coming out all the time. I haven't actually kind of dove down and searched for that particular one. So I will look. But the one I talked about, I'll have to dive in and see if they presented that. I'm getting them confused with the IMSure ones. But I will look into that.
You said thank you.
You're
We had one other question. What factors can you tune to match your small field measurements during commissioning?
To match.
What
So
factors can you tune to match your small field measurements during commissioning?
I'm assuming that means within SIMOCA. I would have to defer to my colleague who is our commissioning and modeling expert. But there are certain things that she can tweak within that to get a better match for that part of the spectrum for your particular. So what you want to do is make sure that you are getting very reliable data for your small fields. So make sure you're using proper detector and your field size is set accurately. But there are ways we can model. But unfortunately, that's out of my scope and area of expertise on a day-to-day basis. But we do have an in-house person who specifically does all of our beam modeling. So she's a great resource, and she knows how your system fits with all the others that she sees. So it's wonderful to have that perspective that expands beyond your own clinic.
We
Yes,
have another.
LinacWatch is the same as LinacView. Yeah, we've branded it for North America here as LinacView.
Awesome. We had one more. How does the calculation work for small targets such as less than 10 to 20 cc?
I'm assuming you're talking about IMSure 3D. I will have to look and see if there's any publications that looks at the small field. I know that one publication that I discussed today did say that IMSure 3D tends to overestimate the output factor by a couple of percent, and Monaco they found underestimates it by about 4%. So if you do have some very small fields, you will see more variance. But according to that article, and when you read it, you can probably dive in deeper and get more information than I'm giving you. But according to that article, SIMOCA actually is closer to what they consider reality. Now, whether that's their measurement or not, because of course we don't know 100% what it should be, because there's variations that go into your measurement versus your Monte Carlo model as well.